Okay. Alright, so these are two guys that are working on the STEM neighborhood project in the tech class. And this class is working with the science and math classes on the same project. I'm going to ask them a couple questions about basically what happened when they were working on the project in the tech class. So first of all, my first question for you guys is, how does this project address STEM, science, technology, engineering, and mathematics?
Well, I guess it combines all of the things into one project so that we have a bunch of different groups working together, and it really helps give a whole scope of how different fields will work together.
Alright, very good. Very nice. You want to add anything, Josh? Or
Yeah, I think because in school all you really learn is 2 plus 2, and in science, NCHL plus water equals something. And
so you basically get to apply
yeah,
what you're learning in those other classes?
Yeah, pretty much. You get to combine them together so you can actually figure out something new that you might actually be able to apply in real life.
Very good. Okay. So basically this project is a real-world, hands-on experience of of different types of careers that are out there in the advanced fields of science, technology, engineering, and mathematics. Okay, so how does your part relate to how does the tech part relate to the math and the science portion? Anyone?
We did all the surveying for this, and then after we developed that, we sent it over to science, and they were basically the EPA, so they told us whether or not it was environmentally sound to put the houses where we have them planned. And then we will send them to the math department, and they'll calculate all of the mathematical parts that didn't relate to actually designing the house.
Okay, so basically the math department's going to take over after you've completed all of the architectural components for tech, and math is going to basically figure out the square footage of the rooms, basically? Is that what you're saying too? Okay. Alright, and so basically, yeah, it's a true integration of science, math, and technology. What types of careers does this project basically relate to? What types of future careers?
Pretty much architecture, landscaping, building and planning, I guess.
Civil engineering.
Civil engineering. Okay, so a lot of different fields of engineering that heavily use different types of technology, different advanced fields of technology. Very good. Okay, so let's take a look at what we have here. So what is this program right here, Josh?
This is Windows, no, Google SketchUp 8.
Google SketchUp.
Not Windows.
And what do you have
this
there?
This is basically the house. It's the same thing on his computer, except I've added walls. I messed up a little bit with the layers. That's why some of these things aren't showing.
Okay.
And it looks a lot less messy.
Yeah.
So the walls are three-dimensional. I have not added the skin yet.
Okay, so like the exterior walls surfaces and the interior wall surfaces for the architectural component.
Yeah.
Very good. And it looks like you have all the rooms named, and the only thing that needs to really happen, like you said, was put the interior walls on and the roof, and just the different textures, or I should say carpet, tile, all the different materials that you get back from math, right?
Yeah, we didn't get to do the deck back here at the garage.
Okay.
To the right though.
Alright, so Rowan, what is this?
This is the floor plan that turned into the three-dimensional wall model.
Okay.
Basically, this is our initial design. We designed it on paper and then went onto here and designed it using all the tool set.
Okay, so what were some of the other programs that you used, Rowan? Could you show me some of them, if you have them up?
Well, we used Google Earth a lot.
Okay, and what is this?
This is basically the Earth program.
Mm-hmm.
It has a complete three-dimensional, if you want it to be, model of the Earth.
And what are all those colors?
These are all of the different lots. So each team of 2 people had a lot, and they designed their own house for it and used the tools to measure the elevations and things to figure out drainage.
Very cool. Could you show me real quick some of the ways that you found the elevations?
Sure.
To go in your places. So you're basically plotting out each one of those corners?
Path tool. So we use this to draw a shape and plot all of the areas on our lot. So this is basically what we did first.
Mm-hmm.
And then you'll save that and go over to, let's see.
You want to go down to places. Scroll down to places. Yep. There you go.
So you use this.
Just pick up your,
And then you click on this show elevation profile, and it will show you all of the elevations for all of the parts of this.
So
And
that's
you
the
can-
whole perimeter of the lot, basically.
Yes, and as we can see, this corner here, right here, is the low point of the lot, so we would want all of the water to drain out there.
Okay.
That's basically what this is telling us.
And what would happen if there were lower points in the lot towards the center where the house would be built? What would you do there?
We'd probably put the house in a different place other than those so that it didn't get flooded when it rained. We want it on a high area.
Okay, so what could you actually add land or add soil to those areas?
We could.
We could, yes.
Or you could build I guess a special type of house that would be able to go over the water as long as it was structurally stable. You could add soil, maybe have some kind of drainage pipe for the whole lot there. You might have to figure out the elevation of the whole thing and figure out the lowest point, but
Okay,
I think that might be something you could do.
very good, very nice. Okay, and can you tell me, so each one of the, what are all these things on the left there? What are those?
These are all other teams' lots
So
that have
click on a couple of those, could you?
been put here. And
Close out the elevation plan.
they have all been plotted out as well. So
Okay.
what we can do is, since they've shared theirs with us, we can also view their elevation profiles for their houses.
Okay, so then you can basically grade the land, basically raise or lower the land depending on where the low points or high points are in each lot, right?
Exactly.
Okay,
You
very
might want to
good.
also check what kind of area is in the middle, if you could scroll out for a second. The middle right around there, because that might be a high point of elevation. Well, all of this is low stuff, so all the water could end up flooding down to yours. You'd be able to see that relatively easily, but from right here on the computer, you'd have to check it out and see.
Okay, and from what I understand, Rowan, you were able to do this in the science class too, so you're able to work on in tech and science, right?
Yes. Basically what we did was we wrote a document with all of the information that they would need from the EPA. We were basically the model EPA for this.
And you were going to
So
give a proposal, is that correct?
we gave a proposal about what should and should not be done
Okay.
for all of the conservation of wildlife, but also the taking care of the area and taking care of the people living there.
Very good.
With
So this project sounds pretty exciting, and I'm very pleased with what I see. Is there anything else that you'd like to share, or is that good?
no,
That's about it.
Very good. Thanks for sharing with us, guys.